So meta-reasoning can be very difficult to talk about because it's circular, so it's often unclear what exactly we're talking about at a given time. So to try to make this process more explicit, let's take an example. Let's imagine a robot whose task is to assemble a camera, and all day every day the robot sits there assembling camera after camera. Then one day the boss walks in and says, instead of assembling that camera, disassemble this camera that's already been put together. So what does the robot do? It wasn't programmed to disassemble cameras, so how does it figure out how to do this task? Well, the robot might have a rule that says, given a new goal or given a new problem, choose the method for which I have the most knowledge. The robot might then look at its memory and say, well, the only thing I have is a bunch of cases of assembling camera after camera after camera. So this is metacognition. The robot has now thought about what it knows, it's thought about its new goal, and it's decided on a method to use to approach this new problem. But now that the robot has selected a method, it then needs to reason further. It's chosen case-based reasoning as its reasoning method. But how will it do the adaptation? Well, the robot might then select a rule out of its memory that says, to reverse a process, do the steps in reverse. So now we've done not only strategy selection when we selected case-based reasoning, but we've done strategy integration. That it's now using a rule-based approach to take care of the case adaptation. So the robot uses that rule, reverses the steps, and disassembles the camera. Now the boss comes back by and says, well, yeah, you disassembled the camera, but why did it take so long? You could have done it so much faster. But the boss doesn't give any feedback as to how the robot could have done it faster. Then later, the boss brings back another camera and says, here, disassemble this camera, but do it faster this time. So now the robot needs to select a method again. It thinks, last time I used case-based reasoning to select my method for disassembling the camera. But case-based reasoning didn't give me an optimal solution. The boss complained that it took me too long. So instead, the robot chunks a rule that says, given a new task of disassembling a camera, suggest strategies other than case-based reasoning. So now it's used a form of meta-metacognition. It's thought about its metacognition. It's looked at the way it selected a strategy in the past and decided the way I selected a strategy in the past must not have worked because the strategy I selected wasn't ideal. So next time, select a different strategy. So here we've seen everything we've talked about today in action. First we saw using metacognition to resolve a gap. The agent didn't have any way of disassembling a camera, so it used it to select a strategy for resolving that gap. That's also strategy selection. It used case-based reasoning to decide what method it should use to resolve this gap. We then saw strategy integration, where it used a rule-based approach to adapt its prior cases. We then saw correcting mistakes, where the boss told the robot that it didn't do it fast enough, so its reasoning method must have been suboptimal, so next time it should try something different. That last part is also an example of meta-metacognition, or metacognition about metacognition. It looked at its strategy selection method and decided, next time I should select a strategy differently.
David's example of a robot that knows how to assemble cameras, but then is given the goal of disassembling a camera, is a good example of goal-based autonomy. Earlier we had looked at how an agent can go about repairing its knowledge or reasoning or learning when it makes a mistake or reaches a failure. But sometimes it is not so much that the agent reaches a failure as much as it is that the agent is given a new goal. When the agent is given a new goal, we do not want the agent to just fall apart. We do not want brittle agents. We want agents that can then adapt their reasoning methods and their learning methods to try to achieve the new goal, even if they were not necessarily programmed to achieve that goal from the beginning. We know that human cognition is very robust and flexible. You and I address a very large number of tasks, a very large number of problems, and achieve a very large number of goals. If we are to design human-level, human-like AI agents, then those AI agents will have to be equally robust and flexible. Metacognition provides a powerful way of achieving that robustness and flexibility. It does so by flexibly, dynamically selecting among competing strategies. It does so by flexibly and dynamically integrating multiple strategies as the problem solving evolves. It does so by using reasoning strategies and knowledge that were programmed into it to achieve new goals.